Good evening. My name is N. Sri Chaitanya. I am studying BTech third year in VVIT. And today I want to discuss about the mock test questions. My questions are space optimization within place operations. Especially when working with large data sets, minimizing memory usage becomes a priority. In place operations and algorithms that avoid additional memory allocation can lead to more efficient solutions. In place array manipulation, these operators can be performed directly on the given array without the need for extract storage. Here a few common tasks within place solution. At first one, reversing an array in place. To reverse an array in place, you can use two pointers that starts from the beginning and the end of the array and swap elements progressively until the pointer meets. And second one is rotating an array by k position in place. To rotate an array by k position, we can perform a reversal in 3 steps. Reverse the entire array, reverse the first k elements, reverse the remaining elements. The time complexity for that is 0 of n, where n is the length of the array. In minimizing memory use to optimize algorithms and reduce memory usage, it's essential to consider both the time complexity and space complexity. There are some strategies in it. Converting a recursive algorithm to an iterative one. Recursive algorithm use the call stack to manage function calls, and in case of deep recursion, example large input sizes, this can lead to stack overflow. We can often convert a recursive algorithms to iterative ones using explicit stacks or queues. For this, the example is factorial calculation. The factorial of a number can be computed recursively, but it can also be done iteratively to avoid stack overflow. Its time complexity is 0 of n for both recursive and iterative solutions, and space complexity is 0 of n for the recursive approach due to call stack, and 0 of 1 for the iterative approach. Avoiding extra data structure. When optimizing for space, it's important to minimize the use of auxiliary data structures. For example, using sorting in place or using pointers to manipulate the data can help. For this, the example is merging two sorted arrays in place. Instead of creating a new array, store the merged result, you can use the input arrays themselves to store the merged data, assuming you have enough space in one of the arrays. The conclusion is by using in-place operations and minimizing additional space, we can optimize algorithms both for time and memory. Common strategies for space optimization and converting recursive algorithms. Performing operations like reversing, rotating or removing duplicates directly on the input array. Converting recursive algorithms to iterate ones to avoid deep recursion and excessive state usage. Minimizing the use of extra data structures and using dynamic programming approaches that use less memory. These techniques ensures that your algorithms are both time efficient and space efficient, which is crucial in environments where memory is a limited resource.